Here we are going to discuss a topic electrical subject, that is AC machines 2. Topic is three-phase induction motors, and the subtopic is advantage and construction of three-phase induction motors. So here objectives: advantage of three-phase induction motors over other motors. Now construction of three-phase induction motors. Here this is the diagram induction motor diagram they given. See, observe this one, how they are here. See clearly, observe this one: stator, rotor, shaft and armature, conductors and stator slots and eye bolt. And see, observe this one very. So this is the induction motor. This is the parts of induction motor. Here shaft, key, so bearings, here bearings, here this is the internal fan, here this is the internal fan, this is the internal fan, this one is internal fan, and here the windings, this is the windings, and here this is stator and starting capacitor, this is a rotor, and wiring junction box, this one is mounting feet, this is mounting feet, and here this is a centrifugal switch and sealed inner housing, this one external fan, this is external fan. So here the ventilations, so this is about the induction motor parts. Advantages of three-phase induction motor: very simple, extremely rugged construction and almost unbreakable construction, especially squirrel cage type induction motor. Now low cost and high reliable, has sufficiently high efficiency and no brushes required in normal mode running condition, hence friction losses are reduced. It has a reasonably good power factor, that means near to 0.8 lagging power factor. So requires minimum maintenance. It starts from rest and needs no extra starting motor. And three-phase induction motors, based on the construction, three-phase induction motors are classified as squirrel cage type, induction motor and a slip ring or wound rotor type phase one type induction motor. Here the construction. An induction motor consists of essentially two parts. An induction motor consists of essentially two parts. A stationary part is called stator and a rotating part is called rotor. Now an induction motor has two main parts. One is a stationary part. So here this is the stationary part. This part is stationary part. This is called stator. Here this is the yoke. This is called yoke. This is called yoke. This one is yoke. So it consisting of a steel frame, the support a hollow cylindrical core. Core constructed from stacked laminations. So it having a number of evenly spaced slots, providing the space for the stator winding. Here a revolving rotor, a composed of punched laminations stacked to create a series of rotor slots, providing space for the rotor winding. One of two types of rotor windings: conventional three-phase windings made of insulated wire, similarly to the winding on the stator. Aluminum bus bars shorted together at the ends by two aluminum rings, forming a squirrel cage shaped circuit. Two basic design types depending on the rotor design: squirrel cage conducting bars laid into slots and shorted at both ends by shorting rings. Wound rotor complete a set of three-phase windings exactly as the stator. Usually, the star connected, the ends of the three rotor wires are connected to three slip rings on the rotor shaft. This way, the rotor circuit is accessible. Now here they are showing rotor. See, observe this one. Here this one is end ring made from a heavy copper. This is end ring made heavy copper. Here this one is bars made from copper or aluminum. Bars made copper or aluminum. This is the bar, copper bar or aluminum bar. So this is the stator type, and this is the rotor type, not stator. Here, and this is the slots, and this one is, see here, this is squirrel cage. This is squirrel cage rotor type, and this is wound rotor. See, observe this one. Cage covered with soft iron laminations. Soft iron laminations. And here this is the wound rotor not wound rotor, squirrel cage. This one is here. So here end rings are short circuited squirrel cage. This end rings are short circuited in squirrel cage. And this is wound rotor. This one is wound rotor. Notice the slip rings. These are the slip rings. This total is wound rotor. And exploded view of three-phase induction motor. Exploded view of three-phase induction motor. Here, see, observe this one. So here, this is end bell, wiring cover, and this one is stator, and this is the stator. And stator electromagnetic in this way, and this here this is called motor frame, and this one is rotor. This is fan blades. Here rotor electromagnetic, this bearing on each end. This is the end, bearing on each end. And now this one is end bell. This one is the end bell. Exploded way of three-phase induction motor. See here in this rotor, so different so ball bearings, bearing outer cap, air cone, and ripper of cover, balling disc, and a spring, bearing inner cap, end bell, air outlet, terminal box clamp, and terminal box. This is the clamp, end bell, air inlet, rotor shaft, grease singer, and balancing disc, bearing out cup, rotor core, bearing inner cap, ball bearing here, and frame. This is the frame, stator core, and rotor fan blades, stator coil, drip roof cover, air cone. This is the so this is about the construction. Here also giving the construction, they given very slip rings. These are the slip rings. This one, and this one slip rings. These three are slip rings. So here brushes, these are the brushes. Here this one is brush, this one is brush, and this one is brush, and this is also a brushes. Cutway in typical wound rotor induction motor, notice the brush and the slip rings. Stator, the stator of induction motor is principle it is made up of a number of stampings which are slotted to receive the stator windings. And stator carries a three-phase winding and is fed from a three-phase supply. Stator is wound for a definite number of poles, the exact number of poles being determined by the requirements of speed. Greater the number of poles, lesser the speed and vice versa. Now, the stator windings, when supplied with a three-phase current, produce a rotating magnetic field which revolves at a synchronous speed. Ns is equal to, that is Ns is equal to 20 F by P. This revolving magnetic flux induces an EMF in the rotor by mutual induction. Now, squirrel cage. This is the figure is showing. These are the that rotor bars. Here the copper entering. This one is copper entering, and this one is copper entering. Laminations forming iron core. This is, and this is welded at all joints here, and short circuit entering copper aluminum bars. So now finished squirrel cage rotor. This is the squirrel cage only rotor winding. See this one. Copper aluminum bars, laminated iron armature. This is a slip ring induction motor. So phase on rotor. Two types of rotor construction are employed. One type is the squirrel cage construction, also called as squirrel cage rotor. So three-phase induction motor employing squirrel cage rotor is called as three-phase squirrel cage induction motor. Now the other type of rotor is phase wound rotor or just wound rotor. So induction motor is employing these rotors are called slip ring induction motors. Now squirrel cage, almost 90% of induction motors are squirrel type. So because this type of rotor has the simplest and most rugged construction, it is almost indestructible. So the rotor consists of a cylindrical laminated core with parallel slots for carrying the rotor conductors. Rotor conductors are not wires but consist of heavy bars of copper or aluminum or alloy. One bar is placed in each slot, rather the bars are inserted from the end when semi-closed slots are used. The squirrel cage, the rotor bars on region are electrically welded or bolted to too heavy as shut out short circuiting endings, thus giving a squirrel cage appearance. It should be noted that the rotor bars are permanently short circuited on themselves. Hence, it is not possible to add any external resistance in series with the rotor circuit for starting purpose. The rotor slots are usually not parallel to the shaft but are purposely to give slightly skew. This is useful in two ways. It helps in reducing the locking tendency of the rotor, and the tendency of the rotor to remain under the stator teeth due to direct magnetic attraction between the two. So here it helps to make the motor run quietly by reducing the magnetic hum. Now phase 1 rotor here. This is the phase 1 rotor. Here this is rotor. This is phase 1 rotor. This is at rotor side. These are the slip rings, and B1, B2, B3 are brushes, and this is the external connected rheostat. This type of rotor is providing with three-phase double layer distributed winding consisting of coils as used in alternators. The rotor is wound for as many poles as the number of stator poles. So rotor is always wound for three-phase even when the stator is wound two-phase. The three-phase are stored internally. So the other three winding terminals are brought out and connected to three insulated slip rings mounted on the shaft with brushes resting on them. These three brushes are further externally connected to a three-phase star-connected rheostat. This makes possible for the introduction of additional resistance in the rotor circuit during the starting period for increasing the starting torque of the motor. Now when running under normal conditions, the slip rings are automatically short-circuited by means of a metal collar which is pushing along the shaft and connect all the rings together. The brushes are automatically lifted from the slip rings to reduce the frictional losses and wear and tear. Hence, it is seen that under normal running condition, the wound rotor short-circuited on itself, just like the squirrel cage induction motor. Here, rotating magnetic field balanced three-phase winding mechanically displaced by 120 degrees from each other fed by a balanced three-phase source. A rotating magnetic field with constant magnitudes which produce rotating with the space. So where Fe is the supply frequency and the number of poles, and NS is called synchronous speed in RPM revolutions per minute. That is N synchronous speed is equal to 120 F by P. So this is the synchronous speed is given for different poles. For two poles 50 Hz 3000, 60 Hz 3600. For 12 poles 500, and this one is 600. Observe this one. Rotating magnetic field, R phase, Y phase, B phase, and the directions. And next direction for 90 degrees. Previous is 0 degrees. Now 90 degrees. Next This is the, observe this one, 0 degrees, 15, 30 degrees, 45, 60, 75, 90, 105, 120, 135, 150, 165, 180, 195, 210, 225, 240, 255, 270, 285, 300, 315, 330, 345, 0 or 360. This is about the advantages of three-phase induction motors over other motors, classification and construction.